Hello dear students, in this video we are going to discuss about stack data structure. And so how this data structure is going to work is it is like last in first out, which means if you consider this as an array, we can able to insert and delete through only one end. We cannot do insertion and deletion in both the ends. Okay, so for example, if you consider we have an array, Okay, let us take an array. Okay, so in this array, we have to know that insertion and deletion can be done through only one end. We cannot insert through this place or this place, anywhere else we cannot do. So both insertion and updation, insertion and deletion we can done through only one end. So here you can see insertion we call it as push and deletion we call it as pop in this stack data structure. And also it follows last in first out. Okay, for example, first I am going to, this is my size of an array, or if you say this is an array. Okay, so what I am going to put is, for example, let us take let me take an array like this. Okay, this is my array, and the array index start from 0, 1, 2, 3, and 4. Now I'm going to insert a one element. For example, I have to insert 10, 20, 30, and 40. So when I do the insertion we call it as push, right? So when I put 10 will be going inside, then 20 will be inserted through this, okay? Then 30 will be inserted, then 40 will be inserted. So who came first will be taken out last, okay? That is, or we can also say who was inserted last will be taken out first. So that is why it is said to be as last in first out. So who we inserted last 40. So when we take out, okay, when we do the deletion, who will be taken out first? Who inserted last will be taken out first. So that is last in first out. So who went inside last? That is 40. And who will be going out first? That is also 40. So that is what called as LIFO. That is last in first out. Who came inside last will be going out first, because here pushing and popping will be done through only one place. Okay. So the next thing is, what is the purpose or applications of the stack is, for example, you all might have experience of working with browser. So in browser, what will you do is, for example, we will be taking multiple pages. For example, when in the Google, we will be searching what is data structure. So then it will lead to the next page. And from that page, we will be clicking something and we'll be moving to the next link. So in that, and after that, when we want to come to the previous page, it will be taken, the last visited page will be coming first, then the next page will be coming first, right? So the last visited from the last visited page will be going one after the other. The first page, first Google page which we logged in will be coming at the last. So that is last in will be viewed first. So page history in the web browser is done through the application of stack. And also whenever we have an experience of typing in Word or Notepad or whatever may be the editor, when we want to do like undo event, the last type will be deleted first. So last thing first out. So when we say Control Z, for example, I am typing happy, H-O-H-A-P-P-Y. Now I am pressing Control Z. So what happened? Who will be deleted first? Y. Because Y only came last, so that will be deleted first. So that is one application. And also in function call, for example, when we run a program, from one function, for example, from the main function, we will be calling another function, for example, stack function. So there we will be having some variables will be created, right? So that local variables will be updated, and then when we come out of the function, that variable will be taken out first. So saving local variable when one function calls another, that is also, and this calls another, so it will be updated top, and when it come out of that, that will be the local variable will be taken out. So there also we'll be using the stack application. Okay, now let us discuss the different operations or functions we can do with this stack data structure. So what are the things we can do is we can create the stack, and then whenever you want to put some elements that we call as push. So that is push is one function, and then if you want to see who is in the top of the stack, that can be achieved using a function called peek. So to see who is in the top of the stack, and if you want to remove an element that we call as pop, that is another function. And then if you want to insert or if you want to delete, if you want to put an element inside the stack, there should be some space, then only we can able to put or insert an element inside the stack. So you have to check is the stack is full. So that is one function. And if you want to remove something out of the stack, we want to check is it empty? If there is empty, we cannot remove anything out of the stack, right? So this will be, we will be checking first is the stack is full or is it empty. So these are the different functions or operations we can do with the stack. Now let us discuss one by one. So initially we saw how our stack will be looking like. Let me take an example. Let me take this as an array. So the array index position, generally we will be starting from 0. Let us take the size of an array as 4. Okay, so it will be like 0, 1, 2, 3. Now, and here we are going to use another variable called top, which will be helping us to understand which is the top element in as of now in the stack. So initially, as of now, let us insert some element also 22, 24, 30. This elements I want to insert the stack. Okay. Initially, there is no element inside the stack. So initially we will be updating the top as -1 because we cannot put top as 0, which means top is 0 is one of the index in the array. So if I put 0 means we know that there is some element in. So initially there is no element inside the stack. So we are going to initialize the top as -1. Okay, and so what is the size of the array? That is 4. That is what it said. Now, whenever if I want to know if the stack is empty, so how will I say now the stack is empty? How will you know the stack is empty? Whenever the top value is -1, then we can understand the stack is empty. Because when there is some element inside the stack, for example, when I insert 21, the top value become 0. Now top is 0. Then I insert 22 inside. So now top will be here. So top will be 1. So when the top will be empty, when the top value is -1, the stack we can understand stack is empty. That is why we are writing a function called is stack. In the stack, for example, let us name the array as stack. And we are passing this array as input. And we want to check whether this stack is empty or not. So how will we check? We are going to check whether if the top value is -1, then we know top is empty. Then how will we know the stack is full? So for example, I have inserted all elements inside this stack of size 4. Okay, now the stack is full. And after that, we know after I insert, top will be here. Every time I insert new element, the top value will be incremented. So now when the top value is, what is the size of an array? 4. Now where is the top? Top is in 3, which means in this position, top is at this position. So when the top value is size of the stack -1, then we know the stack is full. So that is why when the top value is max -1, which means what is max? That is size of an array. Size of an array is what? 4. 4 minus 1 is what? 3. So now we can say when the top value become 3, we know the stack is full, which means the stack top came to the maximum size of an array. Since it is starting from 0, we are putting -1. So now we can understand the stack is full. So this is how we'll be checking whether the stack is full or empty. Okay, so now this shows some of the push and pop element. In this, you consider this is our stack. What is the size of the stack? 6, which means 0 to 5. Now, when you push an element, you can do the insertion and deletion can be done through only one side. So insertion we will be calling as push, and taking out, that is we call as pop, right? So both will happen through only one end here. So now if I want to push D, so D is in the top. And then I will be pushing the element E is at the top. Now, when I pop it, I cannot pop anything in between it. I can only pop the topmost element. So what happened? E will be taken out. Popping means deleting or taking out the top element. So now this. Once more, if I do the pop, the who is at the top of the stack now? D. So D will be deleted. So now this will be the updated stack after I do 2 times of popping. So this is how we'll be doing the push and pop. Let us discuss the code of this or algorithm of it. So for example, this is you consider this is our stack. So now we want to push E inside this stack. So how will we do it? So before you push, as we discussed already, we want to check whether the stack is full or not. If the stack is full, we cannot able to put it inside it, right? How will we check if the stack is full? For that only already we discussed the code. Whenever the top value equal to maximum minus 1, which means in the topmost place, the stack is full, so that we cannot add one more element in the stack because already the stack is full. So that is what we will do doing first. Okay, so if the stack is not full, we'll do some operation. If the stack is full, so if it is returning true, then we say the stack is full. If the stack is not full, that is what we, if the stack is not full, we are calling this function. If the function is returning false, so which means it is not full. So what are the things we will be doing? What will you do first? Now you can see there is one more place available here, right? There is one more place here. So if I want to insert it, what will you do first? We increment this top value first. So we do increment this top value. So that is why we are doing the top equal to top plus 1. So for example, you consider this is 0, 1, 2, 3. Now the top is in 3. We will be incrementing the top value, so it becomes 4. So the now top value is 4, right? So this is 0, 1, 2, 3, 4. So now the top went to 4th position. So stack, this is the name of the stack. Stack is the name of this array. So in the stack of 4th place, top is 4. In the 4th place, we will be inserting the data. What does the data need to be inserted now? E. So now E is, that is the data. So we, in the stack's 4th index position, we inserted this is our data. So this is how we will be putting some element inside the stack that we name it as push. So what do you do? First, you have to increment the top value, and then in that top index, that become the index, right? In the top index, we will be putting the data if the stack is not full. If the stack is full, which means what we know, when the top value is equal to max minus 1, we know it is full. So that case, we will be displaying stack is full. The next one is we want to know whether, so next we are going to discuss about pop. What is the meaning of pop? Pop means deleting one element from the stack. Deleting means always it will be taking the topmost element. So when you cannot do the deletion or when you cannot do the pop, when the stack is empty, we cannot take anything out of it. For example, we saw here, right? When the stack is empty, which means the top value will be minus 1. So in that case, we cannot do any popping operation. So that is what we are seeing first. If the stack is not empty, then only we can able to remove something. Else condition what? We can say empty stack. Okay. So if the stack is not empty, then we can pop it out, right? So what will you do? For example, in this case, if I want to remove or pop, who will be popped out? The topmost element. Who is the topmost element? E. So what will you do first? If you want to print it, we will use a variable called some variable name. Okay, data equal to, we have to take the top element. So how will you get it? Stack of top. So initially who is 0, 1, 2, 3, 4. So 4th place we have E, right? That is we are storing in data. So data become E. Okay. Now, what will you do? We have to decrement this top. So because we are removing this out, then the top should come to the previous location. So we are decrementing top is top minus 1. And then we will be returning the data which we took from the top of the stack. Right? So what are the things you have to do? First, you are going to take the data out, E. So we are taking the stack's top position and we are taking the data. Then in this case, we have E in it. And then we have, since we taken it out, we have to decrement the top. So we decremented it. So top came to this index position 3. Okay. So if the stack is full and then if the stack is empty, we cannot take anything out of it. So these are the things we can do with it. And one more thing, peak. What is peak? taking the, if you want to see the topmost element in just to look only, that is speaking. You're not going to insert or remove it, just want to see who is in the top of the stack, that you can see using peek function. What does this peek function do? You want to check, if you want to see something, it should not be empty. So if it is empty, and then you can say stack is underflow, which means nothing is inside. Other way, so this is to display it. Otherwise, using a for loop from 0th location till the top value, we are going to display the stack value. So initially, from starting from the 0th index till the top value, we can display it. Or if you want to peek it, if the stack is empty, then we'll say it is underflow. Otherwise, peek means always it will give you the topmost element. So you are saying return stack of top. For example, if you have an stack like this, okay, 2, 3, 4 is there, 0, 1, 2 is the index. So where is the top? Top is now in this position. So top value is now 2, okay, which means the second index position. So what will you do? Return the stack. Where is the top? 2. So stack of 2. What is in the stack of 2? 4 is there. So it will just return 4. Just you can see who is in the top of the stack. So that is called as peek function. So these are the operations we can able to do with the stack. So stack means last in, first out. What are the operation you can do? You can push, you can pop, you can peek, you can check whether it is full, or you can check whether it is empty, and also you can able to display the elements available in the stack. Hope you got it. God bless you.